Hello, welcome. Today I'm going to talk about the noSQL storage engines. I'm going to cover the Redis, MongoDB, dynamodb, cosmosdb, which kind of the same thing about noSQL is they're very similar to MongoDB. Also, I'm going to cover up elasticsearch. Also, I'm going to talk about firebase. So those are the technologies I'm gonna be talking about. So okay, let's start with Redis. What's the advantage of using Redis? Although you can use it for storage and this basic storage, the main benefit is that it's in memory. So you get pretty good performance and a great speed. So people use it for the catch in the web pages. So they catch the response from an API endpoint or from the the response itself, the HTML response. So they save that into Redis, which is much better than using catch because it's storage in the disk too. So you don't get the problem of uh, hot or cold startups. So, but since it is in memory, you can use it for catch because you're gonna get, for example, a catch for 1 minute or for 30 minutes for an hour. But there's, all that data is gonna be deleted after some period of time. So if you got it like a catch, it's gonna end deleted after that period of time. What you can also do is use it as a key and value engine, but keep in mind this is in memory. So if you're going to storage all this without a delay, then you need to take into consideration that if you got a big database, then this is gonna consume a lot of memory in your application. So what people are doing, they are storing, you can store, for example, the settings, you can store the permissions, which is kind of not that much information. For example, permissions to the different applications and that kind of thing. You can also store settings, so it's very fast hitting the user data. You could also save the user profile, but you need to limit it in some way, especially if you use the key and value ways. What other ways that people and companies are using Redis for? It's in memory. Some people just store the IDs based on some filter criteria. So, for example, if you got objects and categories, you save the object IDs and the category slash or name into the Redis. So when you search for a category, you actually hit the Redis, it gets you all the object IDs, and later on you can hit DynamoDB or cosmosdb or mongodb in order to get the value, because the good thing about this approach is that it's very fast and you don't use the key value, the mongodb, the dynamodb and all that, just to give you, from an ID or primary key, you get your data. So that's pretty optimum. So it's a good way to do it, but in your code you got some some changes to do. It's not like very maintainable. So it's more for jig people, because it's not easy. It's not as easy to maintain as just saving everything in Mongo or just saving everything in Elasticsearch. But there's an option there, which is good to consider depending on your application. The good thing about Redis, you can replicate in different regions. For example, you can have a Redis in your main region, for example, the US East Coast or Europe, and then you can have different Redis instances just as slaves. So when you're hitting your replicated web places, for example, for your APIs or for your web server, then those web servers, for example, the web server in America, it will be hitting the Redis in America, and then the DynamoDB in America. So that kind of, it's distributed, geographically, and it does pretty good. Okay, the next thing we're gonna cover is the MongoDB. The MongoDB is great. You will keep it in a virtual machine. It is great to start and have a pretty, and for early stage, and have a pretty good, decent database size. But as you grow, you will get into problems, and people started to move from MongoDB to DynamoDB in Amazon Web Services or to CosmosDB. In the case of the CosmosDB, it's pretty nice because you can use the same API you're using for MongoDB. So you can keep using your Mongoose, the Mongo API, and the one that you are used to. But they are very good at distributing data and providing high-speed data access in a similar way as key value, and you are able to filter data and all that. So you have two options. You either keep everything in DynamoDB or CosmosDB, or you just do the Redis, turbocharger, because it's gonna go faster if you can afford the memory implications of having some, the whole thing in memory, just having the IDs and stuff. And then when you're also, you need to save the filtering data in the Redis. So imagine when you have a new filter criteria, guess what? You need to update the Redis for all the items there because, it's just in memory. It's fast, but, it's not very maintainable. And the good thing about the CosmosDB and DynamoDB is, it's pretty easy to use. You use the same, collections. You have, not the schema data, which is pretty cool so that in your applications you don't need to define a fixed structure. As you go, you start adding fields, and you don't need to make migrations and that kind of stuff. Okay, the next thing is Elasticsearch. Why? Because the full text capabilities of Elasticsearch are great. So use Elasticsearch when you are doing keyword searches. That's great because you can have n-grams, you can have tokenizers, you can have these pieces of when you're having a full text like a whole paragraphs. So when you have in an English language, for example, you're searching for car and you want also the plural cars, or you're searching for play and then you want also playing, that kind of thing of stemming in different languages was really great. You can also have great auto suggestion. Now the good thing about Elasticsearch is it's a similar thing than Redis. In Elasticsearch the queries are saved into memory. So when you query some data, the Elasticsearch is saving some of those results in the memory in a very effective way. It is done so that when you filter out later on, like with facets and that kind of thing, then it's going to be very easy to filter out. Imagine you're searching you go to a car site and you search for Mondeo, for example. And then they give you some results. And then after that, you want to say, okay, give me the ones that have air conditioning, give me the ones that got red color. So when those filtering calls you push, Elasticsearch is already having that in memory. So it's pretty quick. So it's a good, a good way, but keep in mind that you need to have deep pockets in order to satisfy the performance that the Elasticsearch is providing to you. If you're just gonna use it as a storage engine and just having only disk, all your data just in disk, and your memory is gonna be small, like 1 gig, 1 GB or something like that, then Elasticsearch is not going to be that fast. But what are companies doing? They are placing the logs using log stats. They are placing analytics data because, for example, something like mixed panel, you can have it easily in Elasticsearch. You just push an event document, and then you push all the properties there inside. So you got that pretty easy. So people use it for analytics. People use it also for filtering because they can do that, and they use it for full text. So it's kind of used for all, and it's pretty popular. Then you got Firebase and Socket storage engines. What's the benefit of that? You get a stream. So the data can be pushed to the client instead of the client pulling the data. And that's a great benefit when you're, well, of course, if you're building your notifications, that's a must. You need to put it in the socket, in WebSockets, kind of a way. You can use Firebase, you can use Socket.io, that kind of thing. You can, you have many different options. But it's also good for the data you are trying to consume. But keep in mind, you still need an API. Because in order to, the good thing is that you, as the data is pushed, you got all that data in the client in JavaScript, so you can filter out, and you don't need to hit the server. But in some cases, you just need to filter out further, and then you need to hit an API in order to filter information from that list. Imagine a Facebook feed or your items feed or your objects. So you can have those kinds of feeds, and it's great because as somebody is adding an object or an item in the feed, the user is seeing that either it pops in the screen, or you see a notification, hey, you got one item, click here. So that's pretty neat. It's pretty neat. So what you do in the client is kind of, I subscribe to this data, and then you start receiving the data. So that's great. And then you need some either Lambda in Amazon Web Services or just a virtual machine in order to push your create and all that, because it's more observability architecture. Yes, sure, you can hit directly the Firebase and right there. But the best thing is just to have in your server side the create endpoints, and those create endpoints are pushing to Firebase and also writing into your Mongo. You get the picture, and then so you push the Firebase, you write into the DynamoDB or whatever, and then the front can use queries to Elasticsearch, to DynamoDB, and also getting data from the Firebase. So you get everything from the base, from all the works. So I hope you enjoyed this learning session about noSQL engines. And as always, do more and move more in market. And also place your comment below. I would love to hear your stories, your experiences with the different technologies I mentioned. Have a good one.